Good morning, everyone. I don't know if anybody was at the bar with us last night, but thanks for making it out so early if you stayed up late. I know our team had a little bit of a hard time waking up this morning, but we're happy to be here. My name is Matthew Spoke. I'm the CEO of a company called Nuco. We're the team behind the Aion project. We're based in Toronto. There's a lot of us here today. So after the talk, if you have any follow-up questions, feel free to reach out to anybody in the t-shirt. I've got one of my co-founders, our CTO, in the back of the room with us, and a bunch of other guys and girls from the team. So please feel free to come ask questions. We've been working in the blockchain space for a number of years now. I started kind of down this path in about 2014, looking at the problems in the enterprise market and figuring out what was it about distributed technologies that would potentially change the kind of underlying infrastructure of enterprises. Started a team to focus on that in 2014, and eventually that turned into our company today. And we came to this realization that over time we saw two ends of a spectrum developing. We saw everything happening on the enterprise private chain side of the spectrum and everything happening on the public blockchain side of the spectrum. And in many cases, very different types of requirements, different types of innovations, but more and more starting to see forward-thinking companies like JP Morgan, like the CME Group, like a whole bunch of others, realizing that there's real validity in the use of public blockchains inside mainstream applications, mainstream organizations. So we started asking questions about how do we start bridging this gap? How do we pull together all of these various innovations into a single solution that could essentially scale all of the applications, all the requirements we have for the future of mainstream adoption? One thing that we noticed along the way, if you were to rewind a year ago to DevCon 2, it probably would still have been debatable how many long-term lasting protocols there would be at the end of all this. Even if you go back farther, the original Bitcoin versus Ethereum debate, is it going to be one chain to rule them all? We came to a pretty obvious adoption realization that there are multiple protocols developing in parallel. There's people building customized systems with customized consensus, with EVM functionality, with Fabric functionality, with Corda functionality, with just plain old Bitcoin functionality. And at some point, we were going to realize that we were running into a very, very new problem in infrastructure around fragmentation of all these technologies. So we decided to build Aion. So we're in the process of developing this right now. There's a lot more information you can find online, but I'll walk you through the problems that we don't think we've solved yet as an industry that we wanted to kind of focus on. And these can kind of high level be bucketed into four general categories. So the first and most obvious one to us is isolation. The fact that we've scaled and built all of these various blockchain networks with no real ability for them to connect to each other without centralized intermediaries, which is kind of the irony of our ecosystem, is we all rely on these heavy centralized intermediaries to go from one blockchain to another. We obviously still encounter an enormous number of problems on scalability. The status ICO is a great example of that, what happened to the Ethereum network on that day. And obviously, there's a lot of plans and development being done to solve that. Privacy, which is mostly a requirement coming from the enterprise market around how do mainstream financial institutions and healthcare organizations and governments eventually trust this technology enough to manage your personal data, to say how are we going to put financial transactions and health records and all of these things onto blockchains. And finally, although it ties relatively into scalability, is this idea of performance. How many transactions can we pass through the network? So I'm going to walk you through our design, our thoughts. There's kind of two major components that we're going to talk about. One is this idea of how do we bridge blockchains together, and the other is a new network that we're developing called Aion 1 that kind of sits at the root of this new interconnected blockchain ecosystem we're building. So this is Aion. High-level architecture and three kind of talking points that I want to go through. So one is the design of what we call Aion 1, which is kind of our new public blockchain that we're building that sits as a little bit of a router inside this network of blockchains. Also has some really kind of core features and functionalities on Aion 1 that I want to kind of dive into a little bit. Secondly is this idea of participating blockchains. Blockchains that will connect through this routing system to essentially be able to witness transactions across each other's blockchains. So, one of the very, very simple problems we wanted to set out to solve was, could I write a decentralized application that pulled input and logic from more than one blockchain without centralizing the application's layer, essentially. So today, if you wanted to tap into the Ethereum network, the Bitcoin network, and like a private Hyperledger network, you'd have to centralize a lot of that logic onto some sort of web-based application. So could you build a decentralized application that said, well, if this happens on blockchain A, then trigger this on blockchain B in like an autonomous, decentralized way? So that's kind of the crux of our design and this idea of bridging participating blockchains into a routing system. And finally, I'll dive a little bit more into how does our bridge mechanism work and what we call ICTs, or interchain transactions. What's the incentive model behind actually creating these bridges and validating transactions and data across multiple chains? So let's start with Aion 1. Two major components that we're in the process of developing. And I'll talk a little bit about where we're at in our development timeline and roadmap. We're having a pretty major release at the beginning of 2018 where you'll see some of this implemented in a live test network. But for now, two major characteristics of the Aion 1 blockchain that we're building. One is a completely new virtual machine focused on higher performance and scalability, parallel transaction processing, inspired by kind of characteristics of the Java virtual machine to pull in some of this enterprise scale that large mainstream organizations have just relied on for a long time. So the idea being that we'll still be able to support languages like Solidity. We're developing a new smart contracting language. A more creative name to be determined. It won't be called the Aion language, and obviously everything would just get executed on what we call the AVM. So that's one characteristic. In the meantime, what we've done while we're researching and implementing this, we've also made some modifications to the EVM. So our first release is going to have a modified version of the EVM, again optimized for performance. So I'll talk a little bit more about that in a second. Probably one of the longer term and more ambitious parts of our project is the new consensus algorithm we're designing. And if you can follow this design, it's a little bit tricky to understand, but you can dive into this a little bit more deeply in our white paper. We're building a delegated hybrid consensus system that essentially gives us the characteristic of instant finality on this connecting network. So when we realized, hey, we wanted to route transactions across many blockchains, the first problem we realized we needed to solve was that we couldn't have at every layer of routing the need to wait for block confirmations, because then this routing mechanism would become completely inefficient if every step along the way I needed to wait 6 to 10 blocks for a transaction to be accepted and then transmitted to the next network. So we had to design a effective incentive mechanism in a consensus model that was instantly final. So you've seen this in some networks, models like delegated proof of stake, with a novelty here that we're building called proof of intelligence. So if you follow this diagram with me, you'll notice here, this is intended to be a brain and then a dollar sign. So we're building essentially a consensus mechanism that has 3 major actors on this blockchain as participating in consensus. One is the validator himself, who participates in the block creation. In fact, kind of good timing that this follows the AMI presentation IBFT. This would not be too dissimilar at the core of the network to something like the IBFT consensus that AMI has been working on. And then behind this validator is the idea that people can support validators by either staking tokens into the system or doing something we call solving, running our proof of intelligence algorithm to essentially prove computation of the network. The long-term goal here is to create deep neural network capabilities on top of a blockchain so that when we get to the long-term potential of this technology, we could be running artificially intelligent applications on top of a blockchain at scale. So we're starting to train these neural network nodes to essentially prove a problem to the network as an alternative to staking tokens. So we're going to have this kind of 3 types of validators that participate in the consensus process. A lot more to dive in on here. But I won't go too deep, but there's also a mechanism of how do you become a validator, how do you nominate yourself, how do you get removed from validation if you're seen to have been malicious or acting dishonestly in the network. So we've kind of laid this out, and we'll be doing a lot more kind of diving in and explaining this in some subsequent papers, but you can read about this online if you follow the project. So this is Aion 1. At the core of this concept is also the fact that the main network has another interesting functionality. And it's this idea of being able to bridge participating blockchains into what we call our connecting network. One high-level philosophy when we set out was that we were going to build a design of a network that allowed you to connect other blockchains, but we also had this philosophy of all chains being equal inside the system, meaning I could build a connecting network, but then somebody else could also connect to me and become a connecting network to somebody else. So instead of this being kind of a 2-tiered system with one network and others surrounding it, we see this kind of evolving more as like a very complex spider web of everybody becoming participating networks to other connectors. So that at some point you can route transactions from one blockchain to another, recognize what's going on, and act on as a result of those transactions. So one of the pieces of research that we did going into this was the fact that one blockchain connecting to another was not all that novel of a problem to solve. There's been a lot of interesting research projects. BTC Relay is a good example of people that set out to essentially solve this concept of one-to-one blockchain connections. How do you trigger a transaction on the Ethereum network as a result of a transaction on the Bitcoin network? That's what BTC Relay set out to solve. So this one blockchain to one blockchain problem, essentially being able to prove that transactions validly occurred on another blockchain, was relatively solvable. What was not solvable, and our hypothesis, is that we're going to have tens of thousands, maybe hundreds of thousands of blockchains at some point in the not so distant future. Some that are built privately, some that are built publicly, some that are built and backed by governments, and some not. And at the end of all this, the concept of the next generation of the internet, as a lot of people like to refer to this technology, is not going to come from a whole bunch of isolated networks, but of one kind of common ecosystem of connected blockchains. So essentially, we've got two different types of blockchains that we're looking at connecting. So one, obviously, is legacy blockchains that exist today. The first bridge implementation we're building is to the Ethereum network. I'll talk a little bit more about how we're doing that at the token level, but also just a generic bridge about how do you recognize state across multiple blockchains. So this is connecting legacy blockchains. We're doing some research and some experimentation of how do we connect Bitcoin. The most obvious blockchains to connect are the ones that have like a second layer smart contract ability to be able to create that logic at a second layer above the network. So Bitcoin obviously doesn't have that natively designed in the protocol, but we do have some ideas of how we could do that. And then secondly is this idea of Aion compatible blockchains. So we hear a lot about new token projects launching, a lot of scaling requirements at each of these individual projects. So if any one of these projects has enough scale that on its own could cause, it could be too large for any single blockchain to share with others at the computational level, we're starting to design this concept of building your own blockchain for your own application. So if you can build your own blockchain for your own application and you can have that blockchain tied into an ecosystem of other blockchains, you start to just take on your own scaling requirements rather than sharing scaling requirements with other applications on the same network. So we'd see this kind of fragmentation of blockchains connecting as more and more people launch their own blockchains with kind of pre-built functionality, with pre-built modular components, whether they're coming from Hyperledger and the Fabric protocol, whether they're coming from modular versions of the Ethereum protocol, or building something from scratch. So the idea is that as other people build their own blockchains, they all become what we call Aion compatible, and they can synchronize into this communication protocol that allows all these blockchains to sync to each other. So let me talk about the bridge for a few minutes. A few things to understand about how this works. There's an economic model that we're building essentially to incentivize people to connect blockchains to one another. So at the core of all of this, inside the Aion 1 blockchain is a system of registries that we use to create bridges, track bridges, and incentivize participants on these bridges. So these registry contracts are essentially smart contracts on the connecting blockchain that act as the identifiers of all these bridges that are being built. Inside these contracts, there's essentially two major functionalities. One is the fact that the bridge needs to be created by a staking of tokens. After that staking of tokens has been put into the contract, other nodes can also participate in that, or other token holders can participate in that bridge by staking into the same contract. A set of rules around the economics of that bridge would be published as part of that contract, so it's up to the creator of the bridge to say, my bridge is going to have this fee structure and is going to be this decentralized, and is, that whole mechanism is free market opportunity for the bridge creator to decide. So we envision that at some point there's going to be a competitive landscape of bridges connecting blockchains, and there's going to be faster bridges and slower bridges and expensive bridges and cheap bridges that connect blockchains one to the other. Inside this registry contract, all of the nodes that participate and stake their tokens will essentially become bridge validators. These bridge validators have the role of witnessing and validating transactions that we call interchain transactions. So they sit commonly on both blockchains that they're bridging. They can witness transactions on one. Lightweight consensus. We're testing Honey Badger BFT on the bridge. So it'll be a single round voting mechanism on the bridge to say, hey, did we all witness the same thing? If yes, then we transmit that message to the connecting network. And the connecting network can then route that to the blockchain that it's intended for. The other part of the bridge registry that's kind of critical is the fact that we use the bridge registry to keep track of the root hash and the state of the blockchain it's connecting. So at any point in time, independently, somebody receiving a transaction could go back to the registry contract and prove through that root hash that the transaction they're looking at is actually included in the state of that blockchain. So the registry will keep track of all these root hashes of all the blockchains it connects to. The interchain transaction is a format of transaction that we're designing essentially to have a common language across blockchains of what a transaction format should look like. So very, very simply, if you think about a single blockchain today, all you really need to identify is who's it coming from and who's it going to. Now we add a second layer of who's it coming from, on what network is it coming from, and who's it going to, and on what network is it going to. So we have to create this idea of identifying blockchains so that we can effectively route these transactions. And the idea of an ICT fee, which is the interchain transaction fee, is essentially a layer above the transaction fee you would already pay inside the blockchain that you're operating on. You'd pay a second layer fee to cross bridges throughout the network. So if you needed your transaction to be witnessed on another blockchain, you'd pay that fee. So over time, what you'll see is you'll see transactions being able to skip from one participating blockchain through a connecting network into another participating blockchain, paying fees and crossing bridges along the way and incentivizing these actors to essentially act as the validators on these bridges. So we're also publishing an economic paper in the next few months that'll dive into the economic model behind this a little bit more. The token. We are building another protocol that we think will be useful to a lot of projects that start off with the idea of creating an ERC20 token on the Ethereum blockchain and eventually want to natively move that token into its own blockchain coin. So the first bridge that we're going to be releasing at the beginning of next year is a token bridge to essentially allow for burn and mint functionality native to the ERC20 contract. So if you can prove to the ERC20 contract that you've burnt your token, then on the other side of the bridge on this new native blockchain, a coin will be minted for you. And kind of more interesting than that is the fact that we want to make this a bidirectional bridge. So that again, if I prove to the protocol that I'm connecting to that I've burnt a coin, then I can actually remint the ERC20 token. So we want to be able to create this fluid concept of tokens being able to transfer from one blockchain to another without changing the underlying supply of that currency. So that at some point, you can see token economies that are scaling across multiple blockchains rather than single blockchains. So this is something we're going to be building and testing for our own token, but is a protocol that we think will be pretty useful and available for other people to apply to their projects as they go from ERC20 to native coin at some point in the evolution of their technologies. So other kind of potential applications we're looking at, obviously there's a lot of talk these days about decentralized exchanges. The only ones we've really seen function to date are ones that operate on top of a single network, so ERC20 exchanges, because they all operate in the same logical environment of Ethereum. But decentralized exchanges across blockchains is not something that we've been able to figure out yet. And that's because we don't have a decentralized home at the middle of all these blockchains. We just have these centralized intermediaries. So decentralized exchanges across currencies and tokens, but like a real decentralized exchange that allows us to connect Bitcoin to Litecoin to Ether to any other blockchain that has a native currency. Interesting to our enterprise clients where we started testing this is this idea of hybrid public and private blockchain applications where you can start writing some of your logic and keeping some of your data on private chains and have some of your logic and some of your data operating on public chains and still be able to build these into a single application. So a simple example we often use when we're talking to our enterprise clients is you can imagine having a health record managed on a private network of hospitals, an insurance policy managed on top of the Ethereum blockchain, and a payment being triggered in some sort of banking network. An application built there would essentially require that I be able to trigger actions on all three of these blockchains pretty autonomously. So, I go to the hospital, my medical record is updated, my insurance policy is verified, and a payment is made. All of this being built in a decentralized app that sits on the Aion network connecting to all these blockchains. So that's kind of this idea of decentralized applications across multiple blockchains. We also see this as a really interesting solution to scale Ethereum. As we see lots of applications that are running into scaling problems as they go through something like an ICO, where really all the Ethereum network needs to know is the final state. So if you can run all of your transactions on another blockchain and then just simply record the final state at the end of your sale, at the end of your application, back to the Ethereum network, you can use this as kind of an on-ramp and off-ramp for Ethereum applications as you're developing them. And then the dream is on-chain artificial intelligence. This is the idea behind what we're doing in proof of intelligence so that you can start to create machine learning functionalities that can be called by smart contracts on the chain without having to take advantage of centralized AI systems that are being developed today. So roadmap, this is our first release coming up in 2018. What you can expect to see there is we'll have a live network operating likely in January, but we'll see. Engineering roadmaps tend to be a little flexible. Modified EVM, big change being moving from 256 bits to 128 bits in the EVM design. We've modified the equihash mining to essentially increase ASIC resistance by increasing memory usage, increasing computational complexity. This eventually will get swapped out with proof of intelligence, which is being developed kind of in parallel, but needs a little bit more time. Still running as a proof of work system before we get to that hybrid consensus. We're going to be open sourcing our Java API, which is like an enterprise API we've used for a lot of our large-scale enterprise clients, focusing on transaction scale. And then finally, we'll be releasing the ERC to Aion bridge protocol. And here's a look at our roadmap over the next kind of year and a half to 2 years. both on the research layer with the papers we'll be releasing and then the releases of all of the functionalities. We expect everything on our white paper to be released by early 2019, but with live iterations of the network kind of going throughout that time. So that's, oh, and then just quick update on progress. For those of you following the project, everything is in development right now, with the exception of the Aion virtual machine, which is still kind of in its research phase. Some of these things are 2-month roadmaps. Some of these things are 1.5 year long roadmaps. So we've got kind of pieces of the team that are working on all these pieces of the project in parallel, and we're constantly giving updates out. So follow us online. We'd be happy to get you guys involved in learning more about what we're doing. This is who's here at DevCon. So we've got, I think, 12 of us at DevCon. Most of them, I think they're all in the room. So feel free to come find us if you have questions. And you can follow us at aion.network. Thanks a lot, guys.